Here is the solution for day 4. Sketch the graph of this function. As sketching aids, look for intercepts, symmetry, and asymptotes. And remember to look for slant asymptotes. So let's look for asymptotes first. Are there any vertical asymptotes? Are there any numbers you can't use for x? So down in the denominator, we observe that x cannot be 0. There's a vertical asymptote at x equals 0. I'll trace the y-axis with a dashed line. Again, it's not showing up very well, but I am drawing a red line right on top of the y-axis. Now let's consider any horizontal asymptotes. The degree of the numerator is 2. The degree of the denominator is to the first power. Because the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Now let's consider if there are any slant asymptotes. There are diagonal asymptotes if the degree of the numerator is 1 more than the degree of the denominator, and that is the case here. So let's find the equation of any diagonal asymptote. Actually perform this division. 2x squared divided by x makes 2x. And 1 divided by x makes 1 over x. Then choose the linear part of this result, which is this right here, the 2x, to make the equation. You can ignore that remainder right there. Y equals 2x is the equation in slope-intercept form of a diagonal line. So it crosses the origin, and then its slope is 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, and so on. Draw a dashed line for that. That is a slant asymptote. When we draw in any curved branches, they're going to get close to this diagonal line. Next, let's consider intercepts. Will the curves cross the x-axis any place? Let's find out. 2x squared plus 1 divided by x. Does that ever turn out to equal 0? It's not, because there is no way that this left side can make 0. In order for this to turn out to be 0, then this part right here, the 2x squared, would have to turn out to be negative 1, because then negative 1 plus 1 would make a 0 in the numerator. But there is no way for this to turn out to be negative 1, because it has an x squared in it. And x squared cannot ever be a negative number. So we figured out that there are no x-intercepts. Now, what about y-intercepts? Does it cross the y-axis any place? To find y-intercepts, you replace x with 0. But we earlier figured out that there's a vertical asymptote when x equals 0, that you're not allowed to use 0. So when we draw the curves, they're not going to touch either axis. Well, that doesn't give us a lot to work on. We need to find some dots. So let's choose some values for x. How about choosing 1 for x? So we have 2 times 1 squared plus 1 all over 1. 1 squared is 1, 2 times 1 is 2, 2 plus 1 is 3, and 3 over 1 makes 3. 1 comma 3 is a dot on the graph. Now we can find more dots, but with that one dot, I think there's going to be a curve that looks like this. Along that vertical asymptote, coming through the dot, and then swinging up along that slanted asymptote. This isn't going to be exact, but it's a good sketch of what the graph looks like. Now, what about, down in this area? What's this going to look like? Well, let's choose a number for x. How about negative 1? So 2 times negative 1 squared plus 1 divided by negative 1. What's this make? Negative 1 squared makes 1. 2 times 1 makes 2. 2 plus 1 makes 3. 3 divided by negative 1 makes negative 3. So negative 1 comma negative 3 is a dot. I think the curve is going to go like this. Along that vertical asymptote, through the dot, and then somehow it's going to curve. Somewhere it's going to curve, and then come along the diagonal asymptote. Here is my sketch of the graph. Now let's take a look at it on the calculator and see how close we got. I've got the function typed in for y1. Notice the parentheses to group the numerator together before dividing by x, and then I'll push graph.